The foundation has been laid. Let's go ahead and step it up with EIGRP as we take a look at summarization, authentication, and some of the other advanced options. As usual, I'm going to keep the configuration interface real active as we walk through this video, but be explaining a lot of concepts in the meanwhile. Well, first off, look at our summarization options, the automatic method and then the manual summarization. We'll then step into our load balancing features, what's on by default and what we can configure. And then we'll follow that up with EIGRP's unique authentication configuration. Some of the other routing protocols are beginning to support this, but EIGRP uses this method known as a keychain, which is very flexible in my mind to allow for dynamic password changes on the fly with EIGRP without you having to intervene to make your network more secure. If you tuned into the previous video on configuring EIGRP options, this topology should look pretty familiar to you, and we're going to stick with it just because it works well for what we're going to do here. First thing I want to talk about in configuring the advanced options of EIGRP is the summarization features. By default, as you may remember, EIGRP supports a feature called auto summary. And as with anything with auto, I always say you auto not use it, because auto summary will automatically summarize back all of these routes into its classful state. So I guess in a way it's good. We have the corporate network and these branch offices. Classful state, that by default is a class B address, so it's going to drop back to 172.30.0.0/16. Now that's fine, but the problem is we just used 8 subnets of 172.30 over here. What if somewhere down the line you decided I wanted to use 172.30 again, maybe over here? Well, you can't, because it summarized it all back to the class B, as in router 2 and router 3 think everything that starts with 172.30 is over in the corporate network. So first thing I want to show you is what this looks like on a live router. Now I'm on the backbone router, starting off right here. You can see that's in the corporate network. And I just want to do a quick show run. Let's begin with the EIGRP options. And I do want to show you that I do have auto summary turned on. Right now it's by default, so I have added a little something since the last video, and that's putting the auto summary back in there. So if I jump over to router 2 and just do a show IP route, you'll see that just as the feature describes, 172.30.0.0 is advertised over. It's automatically summarizing back to its classful boundary. And anytime it reaches well, I guess you could call it a discontiguous network, meaning something that's not 172.30, that's where the summarization point begins. If these WAN links were in the 172.30 space, then it wouldn't auto-summarize because it would think that these are all contiguous networks. Just anytime you reach another classful boundary, it will chop that network off. Now, all of the routers do not need to agree on the auto summary. For example, router 2 and router 3 have auto summary turned off. The backbone router has it turned on. So all I need to do to remove that feature is jump back over to the backbone router, go into router EIGRP, and I'm going to type in no auto summary. Now, as we saw in the base configuration video, don't do that in production because that just took down all neighbor relationships. It stops them and restarts them to generate the detailed routes. And now if I jump back over to router 2 and do a show IP route, what do you expect to see? Every single one of those detailed routes. You can see right here, 172.30.3.0.1. Now, don't try to figure out the order of a routing table. I know many people have asked me the question, hey, why are they ordered that way? That's just the way the Cisco router does it. Sometimes it even splits them to where some routes will be up here, the other routes will be down below. It's very odd. The reasoning behind it is Cisco says it orders it in the easiest way for the router's processor to handle. It tries to order it with the most used routes at the top of the list, but it's not always that way. So there's no real rhyme or reason as to why they get jumbled out of order. So coming back to here, one of the major features of EIGRP is that you're able to summarize at any point in the network. You're going to really appreciate that when we get to OSPF and you find out there's only certain points, only certain routers can do summary addresses. But here, anywhere's fair game. All you have to do is this. I'm on the router 2. Let me jump back over to the backbone router. which is here. I just need to go under the interface that connects to the neighbor I want to summarize for. So in this case, serial 0/0.2, which is 10.1.24, you can see that's the link between the backbone and router 2. That interface is a connection to router 2. So all I need to do is jump under that interface and type in IP summary address. I'll follow it up with a question mark. You can see you can do it for either EIGRP or RIP version 2. I'm going to type in EIGRP followed by the autonomous system and then what I want my summary address to be. This is awesome because there's no, well, outside of RIP, but who uses RIP, really? I mean, there's no other major routing protocol that lets you just splice in a summary address. Now, to hit some of the summarization options from back in the CCNA, remember you want to be as efficient as possible with your summary addresses. The quick way to do that is to find the similar bits. You can see that all of these addresses start with 172, right? They all start with 30, right? Right here is where the differences start on those addresses. So if you're wanting to find a very efficient summary address, your best bet is to break the octet where the differences begin into binary. Now this may seem tedious, but it's definitely worthwhile. Now 0 looks like that, right? 0, 0, 0, 0, 8 zeros. Is that 8? Yes. Now 1, I'm not going to get too tedious on you here. 1, right? 2, 1, 0. 3, 1, 1. 4, 1, 0, 0. 5, 1, 0, 1. 6, 1, 1, 0. And 7, this is going somewhere, 1, 1, 1. Okay? So if you look at all of these binary bits, kind of got a different font there, all of these binary bits, you could say that we'll say the first 8 bits, because they all start with 172, right? If we were to break that into binary, that would be the first 8 bits. The second 8 bits, they're all 30. Those are all the same because that's all similar octet. Now, this third octet is where the difference is. So we can look and we can say 1, 2, 3, 4, 5. Look at where I'm going to draw the line here. All the way down. Every single one of these have 0 as the first 5 bits of the third octet. Are you seeing that? The differences come in the last 3 bits. So if we were to look, we would say the first 5 bits of that third octet is all the same. And then after that, that's where the changes come in. That's, where we get the different numbers in the third and then the host addresses out in the fourth. So those are always going to be different. So let's add those up. 8 plus 8 plus 5. So that would be, carry the 1, 21, right? A best efficient summary address to write to describe this is 172.16.0.0/21, saying the first 21 bits are all the same. Now keep in mind, I designed this example to be this this beautiful. Not all networks are going to be this beautiful. For example, a corporate network, hiring, yay, business is great. We added a whole new department and we added 172.30.8.0. We just blew up our summary address, right? Because if we broke 8 into binary, we do 1, 0, 0, 0. And now it's no longer the first 5 bits of the third octet that are the same. It's now dropped back to 4. You can move that bar back 1 bit because the 8 takes it to the next group. Now also remember, if you were to type in 172.16.0.0/20, which is what we would have to do to move that bar back 1, you would also include 172.30.9.10.11, all the way up to, and think in binary here, where would that boundary be? ... 15. Because 16 would take it to the next octet yet. So if we were to do 172.60.0.0/20 as our summary address, then we would also group all the networks up to 15. Now, what some network admins will prefer to do if they're trying to be efficient with their summarization is to use the summary address, we'll say 172.16.0.0/21, and just go ahead and advertise the 8 as just another network. So essentially the corporate network advertises 2 networks out. the summary, and then the 8. Now, as they add 9, 10, 11, and so on, then they might look at, okay, well, let's go ahead and move that bit boundary back to a /20 and just reduce it to one route that's advertised. And remember, I almost want to take a step back here. Why are we doing this all in the first place? Because the smaller your routing table is, the faster your router. So anything that you can do to make your routers more efficient, that's a good thing for you. So summary addresses reduce the size of the routing table and make your routers faster. They also hide problems. For example, if, let's say, this network goes down, somebody tripped over the cable, wham, 2.0 went down. Well, at that point, router 2 and router 3 don't have to hear about it. They don't get all these routing updates and have to run the dual algorithm because, they don't really care. I mean, sure, they wish they could reach that network, I'm sure deep in the burning desire of their heart, but at the same time, they don't really need to know that that's down. They can send packets to the backbone who knows all about that network, and it will go ahead and drop those. We don't need to disturb these routers with dual updates and query messages, which we're going to talk about in a little while, because what are they going to do about it anyway? I mean, think about it. Does router 2 and router 3 have a backup path to that network? No way. They're stuck. So there's no use in letting them know that that network is down when they aren't going to be able to do anything about it, because you're just wasting processor cycles on the router. So a flyby review of the summarization. Let me now show you the rest of the configuration on the backbone router. We left off right as we were about to finish that summary address command and type that in. So we'll go ahead and type in the summary address we calculated over there, 172.30.0.0. So now it's saying what network mask. I almost did the /2021, but unfortunately Cisco syntax does not allow you to type in bit notation very much. That'll change when IP version 6 comes out. So a /21 is 255.255./21 248.0. Remember, we're doing that summary in the third octet, so that's where the 248 goes. So that is the decimal notation. I'll hit the question mark, and it comes up and says, what is your administrative distance? Now, that is the believability of this summary route. I'm going to leave it on the default because I want to show you something when it's all said and done. I hit Enter, and that will reset the neighbor relationship. Anytime you type in a new summary address, it does bounce the neighbor, so keep that in mind for your production times. And I'm going to now hop over to, jump out here and hop over to router 2, who should be receiving that summary address, do a show IP route and hit Enter. And you can see that we have, all of those addresses still in there. What's going on here? Now, hang on, let me do the show command again. Look at that. What's going on? Looks like we've got all the, detailed route 5, 4, 7. Ah, take a look at this, my friends. There's the summary address right in the fray of things, 172.30.0.0/21. So, we're receiving that summary address, but look at what we did. We just devastated our network, just so you know. Because what we've done is receive the summary address from our backbone neighbor, but notice where all of these other ones are coming from. All the detailed routes are coming in. Whoa, that's not our backbone neighbor. They're coming in Ethernet 0. Let's take a look at our network diagram. Aha! Do you see what's happening here? We configured a summary address going to router 2, this is where the /21 address is going, but we did not configure one going that way. So router 3 is still getting all the detailed routes, and thanks to the beauty of routing protocols, those are coming in this way. Now, think about this. When it comes to what ends up in the routing table, your router goes through a pretty detailed process. Number one, the router wants to know what is the most specific, so you could say specific subnet mask information. That is the number one thing that ends up, deciding what routes go in the routing table. Number two is the administrative distance, and then number 3 is the metric. So looking at this list, router 2 is receiving routes from all over the place. The first tiebreaker, it's saying, okay, who has the most specific subnet mask, and guess who does? The route's coming from router 3. So if you look at this routing table, this guy will never be used because it always has more specific routing information for all of those. So if you want to know how router 2 is reaching the corporate network right now, everything, and I mean everything, is going to router 3 and going out the backbone router. So, we just made this WAN link go completely idle because router 2 isn't using it anymore. It's sending everything across the Ethernet out router 3. So let that be a pretty dangerous warning to you. If you are going to configure summary addresses, beware of the ramifications. Let's hop back over to the backbone router. I'm going to do a show run and focus in on serial 0/0.2. And there's our summary address command. Notice it chose an administrative distance of 5. Now that's for this routing table. So when I do a show IP route, the backbone router will actually keep that in its routing table as a /5. Now we're not seeing it here because everything is a connected network. So those are all being overruled. But that's a very good administrative distance. It's another loop prevention mechanism of EIGRP. That's the default. So I'm going to go under the interface that connects to router 3, serial/0.3, and paste that same summary address in there. Copy, paste, enter. It's the beauty of TerraTerm. Right click is your copy, paste. It's going to bounce the neighbor relationship. Let's hop on over to router 3, do a show IP route now. And you can see router 3 has the summary address right there, the single 172.30. Notice all the more detailed routes have been replaced. And we have a duplex mismatch. But besides that, if I hop over to router 2 now, where we originally did the summary address, now just to get our bearings, I'm back on router 2, who was originally using router 3 and not causing that WAN link to go idle. I'll do a show IP route now, and so much better. Complete relief. We can see that everything is going out serial 1.4 as it should be, and our routing table has sucked down to just a single route representing the corporate office. So our summary address is working. All right, let's go ahead and clear off all this madness of drawing all over the place and move into the next advanced topic, and that's going to be, from the backbone router's perspective, load balancing. Now, by default, EIGRP will load balance across up to 4 equal paths. So as of right now, the backbone router has 2 paths to get to this network down here, but they're not equal. Let's verify that. I'm going to jump up here and just get over to the backbone router and clear off our summarization. There we go. And just do a quick show IP route. It does have 2 paths to get to the 10.1.2 network, which is the Ethernet network back here, but it's only using one of them. And let's find out why. I'll do a show IP EIGRP topology, and you can see that, it's seeing the 2 paths right here, going via that hop and that hop. It's just this one's a better cost. It's saying, hey, I can get there with less cost or a lesser metric going through router 2 than I can through router 3, which has the higher cost. So with that being said, what I can do is turn on a feature called unequal load cost balancing. Did I say that right? Unequal cost load balancing, which means as of right now, I have this one configured as a T1 line, 1.544 megabits per second. This one I set up to router 3 as just 1 megabit per second, so 1000 kilobits per second as the bandwidth, which is why those metrics come in unequally, and it's choosing router 2. By default, the unequal cost load balancing is disabled. So what I can do is go under the router EIGRP process. I'll do router EIGRP1 and use the variance command. I'll type in variance followed by a multiplier. Now this multiplier is essentially saying how bad is too bad, meaning by default a multiplier of 1 says I will only do equal cost load balancing, as in the metrics have to be exactly equal. If I change that to 2 or 3 or 4, I'm saying I will load balance across paths that are 2 times as bad or 3 times as bad. Let me give you an example. Looking at this network, 10.1.2.0, I see that this primary route has a metric of, what is that, 2,195,000, et cetera, this giant metric. Putting a variance of 2 says I will load balance across metrics. I'll just put 2 million or something like that right here. If I use a variance of 2, it says I will load balance across metrics that are 2 times as bad, or essentially 4 million something, and with all the miscellaneous digits coming in here. Now, if I set it to 2, would that include this network and the unequal cost load balancing? Yeah, it will, because it's going to look and say you are less than 4 million, so you are included in the variance of 2. Now, that's what the Cisco documentation will tell you as to how that works, but I have found that I need to reset the process before that will take effect on real routers. For some reason, it doesn't actively start doing that. So let me do a show IP route just to verify. You can see it's still only using the one path in the routing table. So if I do a clear IP EIGRP neighbors, just do a question mark, I'll clear them all, kind of reset, bounce the process. The neighbors go down, and the neighbors come up. Do a show IP route at this point. Aha, and you can see that now we are load balancing across unequal cost paths. Now, thankfully, EIGRP is smart about that. You can see that this one is, I'm not going to say twice as bad because it's not that bad, but it's not anywhere near as good as the primary. EIGRP recognizes that and load balances accurately across that. So, that I'm trying to think of a fraction in my head. Unfortunately, my head can't handle that. A metric of 2 million, a metric of 3 million. So I guess, this one isn't as bad. The fractions in my head aren't working right. So it's not 2 times as bad. It's just somewhere right in the middle of those. A route 2 times as bad would be, I'm going to stop with that. But you understand what I'm trying to say. This one's really good. This one's not as good. EIGRP recognizes that and then uses those metrics to accurately load balance across it. It's not going to be saying, I'll send 2 packets on this one for every 1 that I send over here, because that would be twice as bad. It'll be something in the middle of that. That's what I was trying to communicate. It might send 2 packets here for every 1.5 that it sends here. It knows how to accurately count all that out. So that's all there is to using the variance command. But I must warn you, did you see that range with the variance command? When we typed in variance, I did a question mark and it said a multiplier of up to 128. That's crazy. You could use routes that are 128 times as bad as your primary. I would say at that point, if you're doing that, you're doing more harm than good. I mean, that would take a T1 line and essentially load balance it across maybe a 9600 baud modem. I mean, something that's just terrible. And that's going to end up slowing the link down rather than speeding it up, because the delay across the link that's slow would just be insane. If you were using like voice over IP across that, it would be game over. There's no going there. So the variance command can be used to choose the unequal paths. By default, that is set to 1, which doesn't mean load balancing is disabled. Let me just get back under there. It just says that load balancing will only be done across up to 4 equal cost paths. All right, last thing that we'll talk about is EIGRP authentication. You want to make sure that people don't just bring in a router and have their router jump on the network and participate in your EIGRP routing without any authentication happening. And you want to make sure that it's secure. So in order to accommodate that, Cisco created an authentication method for EIGRP that, number 1, uses only MD5 hashing, one of the most secure hashing methods that we use today for hashing passwords to make sure that nobody else can encrypt those. Now, instead of just going under the routing process and saying, okay, the password for EIGRP's routing domain is Cisco or something like that, and all the routers have to provide Cisco, they use a little bit more complex method, but much more feature-packed and much more secure method than a lot of other routing protocols. The way it works is through this idea known as a keychain of passwords. What you're going to do is go onto your routers and define a list of keys that are going to be accepted for the routing domain. So this backbone router right here might have a list of, we'll say 4 keys since we have it, and key 1 might be the password Cisco. Now, one of the things that you'll define is an accept lifetime and a send lifetime. for these keys. So you'll say, the backbone router will accept the key Cisco from January 1st, 2008 until maybe the end will be December 1st, 2008, or something like that. Now, I'm just throwing an example out there, but you'll have that key that will be accepted from your neighbors for nearly a full year. We're missing a month at the end. So these guys can supply the password of Cisco for those months. Now, the second key in that keychain might be something like, I don't know, Bob. Bob is the key. And I will accept that one from, we'll say, November 1st, 2008 until, we'll say, November 1st, 2009. Now follow me here on this. What we're going to say, and remember, this is the accept lifetime right here. So I will accept the key of Cisco from January 1st, 2008 till December 1st, 2008 from both router 2 and router 3. Now, at somewhere around November, I will begin accepting the key of Bob. Now, notice that this one goes invalid on December 1st, 2008. So there will be a kind of an overlap here where both the key Cisco and the key Bob will be accepted for 1 month. And then as soon as we reach December 1st, 2008, the backbone router says, all right, that's it. This key is no longer accepted, and I'm only going to be accepting the key of Bob from here on out until November of 2009. Now, the reason we do that is because we want this thing to be as automated as possible. One of the painful things is having to go in and set new keys on your routers. On a certain date, you're like, okay, now it's a good time to change the key, and so on and so forth, and you have to go to every single router and change them. Well, this way, it's a lot more automated, and if for some reason the clocks are off on router 2 and router 3. Maybe you're not using an NTP server to sync all the clocks on all of your routers to the same date and time. This gives them a little error buffer. Now, I should say a lot of error buffer. Usually you won't choose a month as an overlap time. You might choose like an hour or maybe a day or something like that, to where if you get off by that bad, then you have like a day error buffer before the key Cisco expires and Bob is accepted. Remember, for this method to work, as you might imagine just by looking at this, we have to have the clocks fairly synchronized on all of our routers. Now, one of the things that you might notice, I'll go to my backbone router and do a show clock, is that just about every Cisco router, when you pull it out of the box, defaults to Monday, March 1st, 1993, if you either A, haven't set the clock, or B, your battery is dead for your BIOS in the Cisco router. So check your batteries, replace them, make sure that you have accurate clocks on all your routers. And that's one of the things I'll set up before we do this example here and walk through setting up the keychains. Otherwise, the authentication will just go haywire. Just like that, in the blink of an eye, I have synchronized the clocks on all my routers. I paused the video, but I can do a show clock real quick, and you can see the time and date on the backbone router is nearly accurate. I'll do the show clock on here. It's synchronized, and all I did, if you're curious, is just went to the backbone router, set the clock on here, and then went to global config mode and type in NTP master to make that a master NTP server. Then from there, on router 2 and router 3, I went in and just typed in NTP server and gave the IP address of the backbone router. 3 simple commands, and wham, all of these are synchronized. Now, it's not so essential, and I kind of use this with tongue-in-cheek, but it's not so essential that all the routers have the right time as it is that they all be synchronized to the same time. Does that make sense? At least when it comes to authentication. If you're talking about log files and so on, you want them to have the right time. But when it comes to authentication, you just want them to have the same time. So you can set up your own little mini NTP network here with just a couple commands and have that time problem solved from there on out. And that way you don't have to worry about router 2 and router 3 drifting from the backbone, or router 2 drifting from router 3 as the clock desynchronizes, if you will, because they'll always be synchronized to the backbone, even if the backbone isn't isn't right, we don't really care because those two are at least on the same time, so they'll change keys at the same time. Because that's the second thing we're going to have to do. We're going to have to go in and set up a keychain on router 2 with exactly the same keys as this. And can we say hello notepad when it comes to this, because it's much easier than typing in all these key strings on all the routers. So let me show you. Let me hop to the main router, the backbone router, and set up a keychain on here so that we can turn on authentication. Now, the good news about the keychains is that you can turn them on and configure them without actually turning on authentication on all the routers. So you can have this all set up and then turn on, wham, one command, one command, one command on every single router, and that's when authentication goes into place. The good news too, you know what, I'm digressing. I'm not going to get into the good news until we get into the config. I'm going to type in keychain. This is a global config command followed by a name. Now, some people name it after the name of the router. Some people name it funny names. I just like using generic names that can apply to all routers so that I can cut and paste the same config to all my different routers. So I'll say keychain EIGRP auth. It is case sensitive, so make sure you remember if you're using capital letters. Now, underneath here, you can see I don't really have many commands other than key. So I'm going to type in key and then a number. It's going to say, what key do you want? And notice we've got quite a few we can choose from. So if you're bored on a Friday night, configure some keys. In the key area, I then type in how often I want to accept and send the keys. This is kind of like, I always have to tie things back here, but the Matrix. Have you seen, oh, which one was that? Number 2, the Matrix 2, the Matrix Reloaded, where there was the key maker, right? There's this key maker who makes all these keys for all the different doors, and sometimes the keys would take you out one zone, and sometimes the keys would take you into another. I'm defining one key right now for EIGRP that's only going to work for the time that I specify. So I have the accept lifetime and the send lifetime. Let's first start off with the accept lifetime. Well, hey, before we even go that far, let's do the string. I'm going to type in key string and then type in Cisco as maybe my password. Don't ever use that as the password, but for this example we will. And I'll say I want to accept that from, and now we type in a date string. You can see the time to start, the time zone in case we're using different time zones. I just let everything be in the universal time coordinated, which is also known as Greenwich Mean Time. I haven't configured time zones, so I don't need to worry about daylight savings time and so on. But can you imagine how much trouble that can cause you if you do have different time zones for your routers, and then on a certain date, boom, everything bumps off an hour. So you may want to specify the time zone if you have those set up. So we'll say the time to start. Now, as of right now, we are at 10:42 a.m. And I would say, a good time to start might be 11:30. This is really cool, and this is what I was going to tell you when I was in global config mode, is we can set all of the start times of our keys to be maybe a safe distance away from when we think we'll finish this configuration. So we can turn on authentication on all of the routers with the accept lifetime and the send lifetime being maybe an hour or 2 hours in the future, knowing that in 2 hours, wham, authentication is going to turn on, and then we're going to have everything synchronized all at the same time. So we don't have an outage. Know what I mean? So, for example, we won't have this outage while we're turning on authentication on one router and the other isn't configured yet, and so we lose the connection until we configure it on the other router. So we can, that's what I'm trying to communicate here. So we have this time to start 11:30 a.m., which is going to be maybe close to an hour from when I am right now. And I'll say the day and month. Well, I will say the month is February. This is just like the clock command if you use that. So make sure you don't type in a number here if you mean the month. At least in America, we always put the month first and then the day second, or other places in the world, they're all backwards. Just kidding. They just put the day first and then the month second. So we'll type in the name of the month followed by the day. The day is February 5th. 2008. This router is not Y236 compliant. And then I have the duration where I can either type in how long I want to set the key to be accepted for, and I can say I want it to be accepted for 3 hours or 5 days or six months, whatever the case may be by duration. But I prefer the time to stop. it's more concrete in my mind. So I'll say maybe 11:30 a.m. on March 5th, 2008. See what I mean? And then I know exactly when it's going to start and exactly when it's going to end instead of having to figure out the duration. So that has configured the accept lifetime, how long I will accept other routers providing the key Cisco to me as the password and still allow them to authenticate. Now, from there, I'll say I also want a send lifetime, and I can walk through the wizard one more time, a send lifetime of 11:30 a.m. And you know what? I could just, whoosh, let's do it this way. Like I said, copy paste is your friend. So I'll say the same thing for the send lifetime of how long I'm going to send that key to my neighbors. That is now key 1. I exit back out, and now I go into key 2. And do you see here how the configuration is going to be a little bit more than we are with typical routing protocols? If you've set up authentication before, you usually just type in, this is the password that we're going to use for the domain. Key 2 is going to be in here, and now I'm setting up a second key. This will do dynamic password changes for me. Now catch this. I'm going to type in the accept lifetime will be from the time to start, we'll say, 11:30 on March 4th. Maybe give a little buffer there, a little overlap, if you will. So it will be accepting 2 keys from, you can see March 4th right here, 2008 until 11:30. And we'll do April 4th, 2008. So you will have a slight shift, and you can set it at 31 days, 30 days, or a month gap. Whatever strategy you want to do, usually an Excel spreadsheet or a whiteboard is handy to draw out and make sure that you are overlapping just slightly on the accept and send lifetime. So you could even go a little further, April 6th, whatever the case may be. The goal is to make sure that you set this up in a way that you're never going to have an hour or a minute or a couple seconds where the keys just die. Do you see what I mean? How easy it would be to slip up on that with these accept and send times to where you just think, oh, well, I'll send it to this day, this time. And you have, maybe a day or an hour or a minute where you have a moment where you haven't reached the accept lifetime for the next key, but one of the routers reached the end of their send lifetime of one key. So you end up in this chaos to where all the keys are mismatched. So what I was saying about the notepad in this is you're going to go through and set up all of your keychains. Then you can take this, whoosh, copy and paste it to a notepad, and then paste it into all your other routers to make sure you don't have any mistypes. You're not misconfiguring the times because you forget what you put in there. Copy and paste is the best way to do this to get consistency between all the different devices. Now, once you have all of your keys set up, to turn on authentication, all we need to do is go under the interface we want to enable it for. That's the good news about this, is maybe on some links I don't need authentication because I know, for instance, the point-to-point links are secure because no one can get to them. They are point-to-point through a service provider. However, this is an Ethernet connection right here, which maybe bridges, if you designed it right, it should be through a separate VLAN, but maybe you accidentally bridge it through your user segment or something like that. So you want authentication here. If that's the case, I can just go under the Ethernet interface and turn on authentication just between the neighbors on the Ethernet interface. Whereas the other neighbors up here won't need authentication. But you go under the interface that you want it for, and I'll do serial 0/0.2 in this case, and you type in the command IP authentication. First command, there's actually 2, IP authentication mode EIGRP. You type in the autonomous system, and then it will just type in what mode do you want. I don't know why this command exists in the sense that it does turn on authentication, but it's saying that I am going to accept MD5 authentication for this neighbor. There is no other option. Now, I'm trying to remember in years ago if they ever had clear text authentication for EIGRP, and I don't believe they did. I believe they always just had, unless it was very old. I'm going back in my own mind. But it's always been MD5 as far as I've known. And then you can type in follow-up command, IP authentication keychain And we type in EIGRP in the autonomous system we want, followed by the name of the keychain. And that's where we come up here and say, I want the keychain EIGRP authentication, and hit enter. And now that keychain has been applied to our neighbors. Now keep in mind, did you notice when I typed in this first command, the neighbor just died. The neighbor went down. It says authentication mode changed. And notice we never saw an up message come back. That's not good, in the sense that the neighbor is now down because we've told it to require authentication, and but we haven't assigned it a keychain yet. We haven't said this is what I'll accept, this is what I'll send, and all of those different criteria. So as of right now, the neighbor is down and has not come back online because we have not configured router 2 for authentication. And I'm gonna leave that to your own imagination, if you will. I don't want this authentication to go on forever. You can see that the main work that you're going to be doing here is going to be configuring the keychains on all the routers. Once you've got that done, you can go in, type in the keychain. I would recommend putting the keychain on there first so it knows the accept and send, then enable authentication for that interface, and you will be good to go. All right, well, let's wrap things up on that note. We have hit 3 major features of EIGRP. We first looked at the summarization options, which by default use auto summarization, which I don't like. So you might remember from the previous video I mentioned no auto is one of my best friends when it comes to configuring EIGRP. The manual summarization is enabled on a per interface basis, so we can put summary routes wherever we want in our routing domain. From there, we got into the load balancing features, which by default, EIGRP will load balance across up to 4 equal paths, but we can turn on the variance command, allowing it to load balance across unequal paths, one of the features unique to EIGRP that no other routing protocol supports. Finally, we looked at the authentication configuration, just got done with that. We looked at the MD5 hashed method. First off, that is one of the most secure methods that is out there for authentication, but then also saw the flexibility of EIGRP in the options to turn on authentication using keychains rather than just typing in a password under an interface that has to be changed on every routers manually on a certain time interval. This way allows you to automate the whole process. I hope this has been informative for you, and I'd like to thank you for viewing.